In this video, we are going to cover Hess law. At the end of this topic, students should be able to A. Define Hess law, and B. Apply Hess law to calculate enthalpy changes using the algebraic method and the energy cycle method. Imagine that we want to travel from Malaysia to the United Kingdom. If we want a single flight, we can use Malaysia Airlines. The journey will take 12 hours. But if we want to make a transit at UAE, we can use Emirates Airlines. The flight from Malaysia to the UAE takes about 6 hours. And the flight from the UAE to the United Kingdom will also take about 6 hours. This means that either we took a direct flight or a transit flight, the durations are still the same. The same concept applies to Hess law. Hess law states that when reactants are converted to products, the change in enthalpy is the same whether the reaction takes place in one step or in the series of steps. The duration of the flight is the same as the change in enthalpy, and the flight taken is the same to the step taken. Note that the enthalpy change depends only on the nature of the reactants and product and is independent of the route taken. For example, from 1 to 2, there are two available routes. The first one is route A, the clockwise arrow. The change in enthalpy from 1 to 2 using route A is equal to delta H1 plus delta H6. The second route is route B, the anti-clockwise arrow. The change in enthalpy using route B from 1 to 2 is equal to delta H2 plus delta H3 plus delta H4. According to Hess law, regardless of the route taken, the change in enthalpy are still the same. Therefore, the change in enthalpy for route A, delta H1 plus delta H6, is equal to the change in enthalpy for route B, delta H2 plus delta H3 plus delta H4. These enthalpy changes can be calculated using two methods, algebraic method or energy cycle method. For example, find the standard enthalpy of formation of ethane C2H6 gas given the following data. Delta Hc refers to combustion. To solve this question using algebraic method, the first thing is to write chemical equation for the given enthalpy change. Note that delta Hc is combustion, so the chemical equation is the reaction between the reactants and oxygen. For example, the combustion equation for carbon is the reaction between carbon and oxygen to form CO2. For hydrogen, the reaction is hydrogen plus oxygen to form H2O, while for C2H6, the reaction is between C2H6 and oxygen to produce carbon dioxide and water. Then we write the chemical equation for the formation of ethane. 2 carbon plus 3 H2 produce 1 mole of C2H6. By referring to the chemical equation for the formation of ethane, we know that we need 2 carbon. So, the equation we want to use is the first equation, and we multiply the first equation with 2 so that we can get 2 carbon. Remember that the value of delta H is also multiplied by 2. Then we need 3 hydrogen. So we use the second equation and multiply by 3 so that we can get 3 hydrogen. Remember to multiply the delta H with 3. Lastly, we need C2H6 on the right side of the equation. By using the third equation, we reverse the equation so that C2H6 is on the right side of the equation. Next, we can cancel the same species that is on a different side. For example, there are CO2 on the right and on the left side. So we can cancel CO2. Next, we can cancel H2O. And lastly, we can see that on the left side, we have 2 oxygen plus 3/2 oxygen equal to 7/2 oxygen. This we can cancel with the 7/2 oxygen on the right side. The final equation will become 2 carbon plus 3 H2 produce C2H6, which is the same equation as the formation of ethane. By totaling up the delta H, negative 7x6 plus negative 858 plus 1560, we will get the delta H for the formation of ethane, which is negative 84 kJ per mole. The second method is energy cycle method. First of all, we write the equation for the formation of ethane. 2 carbon plus 3 H2 produce C2H6. Then we relate 2 carbon react with 2 oxygen produce 2 CO2. And then we write the equation for 3 H2. 3 H2 react with 3/2 O2 produce 3 H2O. The product 2 CO2 and 3 H2O can be related to the C2H6 from the third equation, which is C2H6 plus 7/2 oxygen produce 2 CO2 plus 3 H2O. Now we have a complete cycle. If we look at the arrow of the equation, there is 2 ways. One is the blue arrow, root A, and one is the green arrow, root B. The delta H for root A is equal to the delta H of root B. So, if we want to find the delta H formations, we can write delta H formation plus negative 1560 equal root A, negative 786 plus negative 858. And then we will get delta H formation is negative 84 kJ per mole. So basically, if you want to use energy cycle method, you must use algebraic method first so that you won't get confused in writing the energy cycle. That's all for this video. Thank you.